Okay, so I'm going to go ahead and get started. Hopefully you guys can hear me. Yep. So today, like I said before, our handouts we're working on today is Quiz 7.3 and Notes 8A. So those are the two things that you need to have, the two handouts you need to have for today that we'll be using. And then, actually, Jay, can you go ahead and read the rest of this for me real quick?
Where did you stop again? I'm sorry.
Just read the agenda.
Agenda. Okay. Today's handouts: Quiz 7.3 and Notes 8A. Quiz and finish 7.3 confidence intervals from mean, using the TI calculator to find mean and the standard deviation, and the confidence interval. 8.1 hypothesis testing steps. 8.4 hypothesis z-test for proportion. Then due today, connect math 7.4 and 7.1 and 7.4. Then due Thursday is connect math 7.3. Due next Tuesday, connect math 8.1 and 8.4. Due April 14th is the project lab part 5. And then fill out the office hour survey, pick up the handouts if you want at Professor Young's doorstep in the complex and not on the street.
Right. So quick, thank you so much. Right. So if you need the handouts, they're on my house doorstep, but my house, the front of my house is in the complex itself, not on the street. So if you look at the announcements, it'll kind of give you directions. You have to drive into the complex, and then my building's on the left. And also the office hour survey. So where do you find those? If you go to Canvas, under announcements, there's a couple announcements. So I have two announcements. The first one I posted was the one from last week, which talked about, what did it talk about? It talked about just a handful of things that needed to happen. It's taking a while to load. Sorry about that. So, please let me know if you're getting these emails. So that one, you also got all these as emails as well. But if you look at that, the very bottom of that is talking about handouts. And if you want to pick them up, this is where you can get them. That's my address and everything else. So, and again, they're there all the time in a white box on my front porch. So you can come by anytime you want. Doesn't matter when, and how to get in there. And then the other thing in the announcements is this doodle poll. I want to have office hours that you guys will come to. So if you can fill out this doodle poll, it gives different times. Don't worry about the dates because it'll be the same, whether it's Mondays all semester long, Tuesdays all semester long, Wednesdays all semester long, or Thursdays all semester long. Just click on the ones that work for you. And that's in the bottom of the second announcement, which was the last major email I sent to you guys. And I don't know why it's taking so long to load. But if you look at the one where I said need answers, and there's kind of numbered 1, 2, 3, 4, 5, 6. I numbered all those, and a lot of you guys responded to the 1, 2, 3 for me. Look at the very bottom of that. Number 6 is my office hours, and there's a link to my to this poll down there, so I can pick out when you want me to do my office hours. Okay, so enough of that. So today, again, we're going to look at this quiz here, and let's take a look. I don't think I did that yet. So the first thing we'll go ahead and start in is the confidence interval for proportions. So this was we did this kind of really in the 7.1 lecture. So we actually did this in class for you guys. But remember we talked about how the error is equal to your z-score. And really, this is not really a z-score. This is really your critical value, right? So really, you should be thinking this is the critical value, which my handwriting is terrible with my mouse, but there you go. Think of that as critical value, which is just that number that you get from the, this is just getting worse, isn't it? The number you get from our our handouts in Chapter 7. So if you kind of look back on the Chapter 7 notes, which would be here, the second page, you'll see it's just the critical value for proportions. You just grab it off this table here. And it's just all right in here. So if I have a confidence level of 95%, the critical value of that for a proportion is going to be 1.96. If I have a confidence level of 99%, the critical value for that is going to be 2.58. Remember we talked about rounding that to 2 decimal places just to keep your homework happy. And then you multiply that by the standard deviation. So for a proportion, the standard deviation is square root of p hat q hat over n. So a lot of times we want to figure out for a given error, like I want to know with an error of only 2%, what proportion of people plan on voting for Joe Biden in the next election. So I want to know within a certain percentage, within a certain error. So the within is where you find your error. And if I want to keep my error within a certain amount, I can't mess with my critical value. That's off that table. It's fixed. 95% confidence interval, it's 1.96. I can't change that. P hat and Q hat, again, I can't change those either. I can't tell someone, oh, I need you to vote yes, to say yes, so I can have a higher P hat. You can't do that. But you can ask more people. You can take a bigger sample size. So N is the one thing you can change to make your E change. So the larger your N, the smaller your E. So if I solve this if I squared both sides of this equation and then multiply both sides by N and divide both sides by E squared, I get this down here. So that's the one you want to use. And again, if you have an estimate of P hat, you just use this one. If you don't know what P hat might be, then you just use the worst case scenario, 0.5, 50-50 for point P, for P and Q. So 0.5 and 0.5 for P and Q. So you'd end up getting, well, you just plug it into here, and you'd end up getting this down here. So your question, oh wait, one more thing. Rounding off rule, remember we have to round up because you cannot sample a portion of a person. You have to sample the whole person. And again, 237 is not enough because if I had 237 people, I need to have at least 237.164. So this is not enough. I need to have 238 people because that would be actually, that would be at least 237.16. So I need to have 238 people to stay within that error. So we'll take a look at your problem. Does anyone just want to share yours? Anyone? At all? You guys want me to do it? Let me see if I can get my board to work. Okay, so here's our first problem. So you guys are being kind of whistles and limps. If research wishes to be 95% confident, you know what? Let's get one of you guys to read this for me. Angel, go ahead and read for me.
A researcher wishes to be 95% confident that her estimate of the true proportion of individuals who traveled overseas is within 4% of the true proportion. Find the sample necessary if, in a prior study, a sample of 200 people showed that 40 traveled overseas last year. If no estimate of the sample proportion is available, how large should the sample be?
Great. Thank you. All right. So first of all, how do I know that this is a confidence interval and not a hypothesis test or something else? Because it says, oh, it's just totally acting up on me. Super annoying. Because it says estimate. Estimate means confidence interval. Right? Anytime you see the word estimate, that's saying find the confidence interval. So here we need our confidence interval will be 95%, which means I need to find my critical value. My critical value, this should be red. Critical value then will be for a 95% confidence interval, to look it up on my little handy-dandy table, which again was right here. Oh, no, not right there, sorry. Right here. 95% confidence interval level would be a critical value, right? It's also called Z alpha over 2, but remember, it's a lot easier to think about it as your critical value is 1.96. So, close those guys up. So my critical value is 1.96. And then let's take a look at what else we have here. We've got within 4%. Remember, when you find within, you find your error. Within is your error because it's how much that person is adding and subtracting from the point estimate. So let me just flash back to me for a second. All right, so can you guys see me? Can everyone see me? Not yet.
Yeah.
Yes, no? Can you see me big or small?
Big.
Big? Okay, great. So remember, your point estimate, which is either p hat or x bar, is your best guess. It's the one number that's your best guess. I think it's right here. What's that going to be? It's going to be your whatever you got from your sample. If you take a sample and you get a sample mean, a sample average, that's your best guess. So you get a sample, you get a sample proportion, a p-hat, that's your best guess. So first of all, what's the difference between a proportion and a mean? Like, how do I know what kind of question, if I'm a researcher, what kind of question have I asked to get a proportion? So not what am I asking you, but what is the researcher asking the people? What do they ask? What kind of question is a proportion question? Anyone? You guys remember this?
Yes or no?
Yes, a yes/no question, exactly. So I might ask them, you know, did you draw a blue marble? Or are you a student? Or did you vote in the last election? So that's going to be a proportion. I'm going to have yeses and nos. My proportion will be the percentage of yeses. So the percentage or the proportion of yeses, so it might be like 34 out of 67, that's a proportion, right? Change it into a percentage. You know, 72%, 34%, 65%, that's my proportion. If it's a mean, an X bar, what kind of question, what's our data look like? Our data are not yeses and nos. What kind of question am I asking people? Anyone?
Numerical.
Numerical, exactly. So it'll be like, what's your age? How many classes are you taking? How tall are you? Those are going to be numbers, are going to be your answers. So you can find the mean of that. So you take all those numbers, your data, and you find the mean of that. That's your X bar, your sample mean. That's your, again, so if you're trying to figure out for a mean, your sample mean would be your X bar. That's your best point estimate of what the whole world's population is. So if I took a sample of 30 people and their average height was 67.4 inches, then my best guess of the whole world's average height is going to be 67.4 inches, right? Whatever you got from your sample. So that's my best point estimate. And then I'm going to take a little interval around that. I'm going to go a certain number of standard deviations this way, a certain number of standard deviations that way, and I'm going to come up with this confidence interval, this interval. I'm going to say, I really think that the whole world's mean is between these two numbers. But it may not be exactly here. I'm going to take a little bit of an interval around it so I can be more sure that I think it's at least, you know, from here to here. So you're going to do a certain number of standard deviations this way, a certain number of standard deviations that way. The number of standard deviations you go, that amount is called our error. Right, so the number of standard deviations you want to go multiplied by what a standard deviation is. So I'll have this and I'll go this much this way, that much that way. That's my best guess of, I think it's really going to be somewhere in this range from here to here. So what we're looking at here is, let me go back to our screen. Is trying to figure out what my error is. So I want my error, the part I'm adding and subtracting, to be no more than 4%. 4% or 4 cents. So here I'm going to figure out what that is. So my error is 4%. All right, that is 4 cents, 0.04. So that's my E. And then the last thing we need to figure out is, okay, so here in a prior, so this is prior studies. This is not my study, it's a prior study. We had a sample of 200 people with 400 that traveled overseas. So that means that my p-hat, my proportion that I'm going to use as a guesstimate kind of, is going to be based on a prior study. It's not my sample, it's a previous sample, was 40 out of 200. 40 over 200. So in other words, 0.2. Oops. So if my p-hat is 0.2, what's my q-hat have to be? In other words, if I have a 20% chance of success, what's my chance of failure? 0.8. Exactly. Those have to add up to 100%. If there's a 20% chance they did, they say yes. There's a 80% chance they say no. So those are my basic numbers. So now in order to do my calculation, then I just, oh, that kind of got messed up. There we go. Then I can just use this. So n equals, oops. And you can do it either way. So I think the book does it like this: critical value over E squared, oops, this is terrible, times p-hat, q-hat. So some of you guys did it this way. You also could have done this like, you could also could have done critical value squared over E squared. You get the exact, these are the exact same thing, it's just rearranged slightly different, times p hat, q hat. And you can do either one of those. Either way you'll get the same answer. What did you guys get for this one? 300 and something, 300 and what? What was that?
385.
Yeah, so 384 point, was it 12? 384 point 16. Great. And again, remember, you can't have a fraction of a person. You have to have at least 384.16, so you need to have 385. That's the correct answer. Now the second one is similar but different. For that one, let me see if I can get this to work. I don't know why this won't work. Oh dear, that's worse. Okay. Yeah, my Mobi's not working. Sorry. Okay, so for the second one, my p-hat and q-hat are going to be slightly different. I don't know, I can't assume anything, so I'm just going to use p-hat and q-hat equaling to 0.5. And if you do that, you plug those into the same exact problem. This is really terrible. So then your n is going to equal my critical value, 1.96. I wonder if I can do it this way. Let's try this. .96, and then this one's going to be my error, 0.04, and then I have 0.5 times 0.5. Okay, I'm just move these pieces around a little bit. So I have this squared over this squared times those two. And for this one, you guys got, what'd you guess for this one? Jay, what'd you guys get?
600.25.
600.25. So then we're going to say that's equal to 601. Okay. Everybody all on board with that one? Do you guys have questions? You guys want to, like, anybody have a question?
I have a question.
Yeah, go ahead.
So the 0.5, like, that's the margin of error?
No, this one right here. This is our p hat q hat. If we don't know what p hat q hat is, that's our guess. The 0.04, that's our error, because that comes from within. You find within, you find your error. So it says within 4%. My error is 4%. So 4% is written as 4 cents, 0.04. Right, that's 4 cents. So that's my error. So that's going to be the number that goes down here, 0.04, and it goes down here, 0.04 squared.
Okay, so 0.5, do we always use that when we don't know what the percent is?
Yes, because the worst case scenario, if you don't know, you just use 50-50, right? 0.5, 0.5. Yeah, absolutely. Are these legible, this 0.2, is that really, that's probably not very legible.
I also have another question.
Yes.
So my Wi-Fi is actually terrible right now. I've been catching every their word. So are you going to be recording lectures so that I could catch up and rewatch?
I am. So if you're having trouble with that, the best thing to do, this is what I do. I go to my audio, and instead of audio, I click and say audio settings. I go to my phone. I switch to my audio on my phone. So can you guys see this or not? You probably can't. That actually doesn't help me. But I guess you can't do it from here. What I can, nope, that doesn't help me. Shoot, maybe you have to do it later. I thought I could do it before. Is muting this one and then dialing on your phone. So if you dial in on your phone, the number, let me find that. So if you go to our class, set to the other class, but that's okay. A couple things I want to point out anyways, so this is good, is here's right at the top now I have the links to Zoom lectures and office hours, and then also look down here, do you guys see this T-table down here? That's where you download the T-table if you don't have one, and you guys all need that. So under handouts, that's that bottom thing down here. But if you go to this one here and you click on it, it will give you all of our Zoom, all the Zoom links for all of them. Audio, if you connect your audio through your phone instead and dial in, it will totally make everything run faster. It's amazing. So if you're glitchy, definitely do that, and it will smooth out the video a lot, and the audio. I have a lot of things open, so it's giving me some hassles, but you dial this number right here, right there, on your phone.
Okay.
Put in the meeting number, so our meeting number is right here, 390-643-002, and then connect, and it'll ask you for your participant number, and you should have it, yeah, it should tell you what yours is. If you click on this, it should kind of give you some options, and it might let you, oh yeah, see, so here, if you click on this, your mute on your phone thing up here, it'll give you this, and you can, most of you are probably connected to your audio, and then you can just flip over and connect to your phone call instead, and it should tell you what your participant number is, and then you connect to there, and it's a lot, it makes a world of difference. So definitely, I would suggest that you guys all do that.
Yeah, I'll try that out. Thank you.
Okay, yeah, sure. Okay, let's take a look at our next thing here. We already did that. All right. Okay, I'm gonna stop let me stop the recording.